11.6 is going to now be looking at another operation with these rational expressions, and it's adding and subtracting. So the objectives are down below. I think the biggest thing here is there's just a lot of review and past skills that are going to be coming together now that you're going to have to be using. So finding the common denominator here, that's going to be the newest thing, just because it's a little bit different when we're working with these factors and polynomials. Biggest thing here is going to be you're going to need a common denominator for when you're adding and subtracting. Keep in mind, subtraction is the same thing as addition. We're going to be turning the subtraction into addition problems by that keep switch switch method, because the same thing, if you took 4 minus 3, that's the same thing as this, adding negative 3 to it. Keeping that first number, switching the sign to addition is the same thing when you negate the following sign. So we're going to be doing that. Just watch out for a distribution, and we're going to be doing a problem like that in a second. So as long as you have a common denominator, we didn't have to worry about that in the last section, the 11.5, where we multiplied and divided fractions. But when we're adding and subtracting, you need that common denominator, in which case you just add or subtract straight across the tops, simplify those, and then as long as you have that common denominator, you're good. So here's that example, or the first example that we're going to do. The first thing that I want to acknowledge is I am going to switch this addition to, switch that subtraction to addition, but then you have to negate this whole chunk that's over here. So you're negating this whole thing that we have over here. So now here's addition, and we do have common denominators. They're exactly the same on the bottom. So I'm going to go ahead and just add what I have on the tops. Okay, and I'm going to put it over that common denominator. Alright, now here is where we need to be careful. You have this negation of this whole group. So that negation, technically we have a -1 here that you need to distribute to everything. This negative is not just attached to the 3x. This negative is also subtracting the 1. So in this case, what you would have is x plus, we have -1 times 3x, it's -3x. Plus, we have -1 times 1, it's -1, all over x squared minus 9. Do not forget to simplify. Okay. Simplify means combine like terms. So on that top there, if you have any like terms with identical variable parts, you see this and this, technically there's a 1x out in front of here, we can combine those because this x and this x is exactly identical. Had there been a 2 here, so 1x squared, then we would not have been able to combine them because an x squared is not the same thing as an x. They're just not like terms. So when you do combine 1x plus -3x, you just look at those coefficient numbers in the front and you add those. So 1 plus -3 is -2x plus, and then we have -1 all over x squared minus 9. Here is where you do want to simplify if you can, if there's any common factors on the top and the bottom. I'm going to look at the top here and say, is there any common thing between this -2x and this -1 that I can pull out? And no, I can't. There's nothing in common. If you factor tree those, you would have -1 times and then 2 times x is that first thing. And then for -1, you would have -1 times 1. So if you fully factor those out, then you could possibly pull out a -1. If you want to, that's fine. So I can do that. -1, 2x plus 1 is all you'd have left. If you ripped this out and you ripped that out, what you would have left is your 2x plus 1. Notice if you distribute that all in, you would get the same thing up here. Can you factor this? Well, x times x, if you factor treat x squared, and then minus 3 times 3, no, they don't have anything in common. But now here's another question. Because it is a quadratic, could you FOIL this? Could you factor this using this x plus something times x plus something? And you could. Think of the numbers that multiply to be -9. I can think of -3 and 3, and when you do add those you get that 0 here. So that's what we want. Alright, now you're going to ask yourself, is there anything that I can cross out here? No, there's not. This is done. Okay. Alright, number 21, we're going to come across an issue here. So when I do this, I'm not going to complete it here. Number 21, we come across this issue that we do not have common denominators. So I'm going to wait to do this for a second. We can't just go ahead and say, well, 9 plus 3 and then throw it over whatever's on the bottom, because we don't have the same thing on the bottom. So here is where you have to find a common denominator, add and simplify the tops and put So if you have a common denominator, you just add and simplify the tops and put over the common denominator, or what we call the LCM. If you do not have a common denominator, this is where you're going to have to find it and rewrite it. So you're going to have to rewrite each one of your rational expressions, or each one of those crazy fractions that we're dealing with. You're going to have to rewrite them so that they do have matching common denominators. So let's find the LCM. So first of all, factor the denominators completely. This is going back off of the problem that we were just looking at, number 21. So when you look at the denominators of 21, we're going to have to find the common denominators of these two fractions that we have. Okay, so this and this, that's what I'm going to have to consider. Find the LCM of those. So you're going to factor the denominators completely. This, I'm going to ask myself, is there anything in common when I look at x squared and 3x? So I'm going to factor tree those both. Is there anything in common that I could pull out of both of them? Yes, there is. There's that x. So I'm going to pull out that x, and when I pull out this x and this x, what I'm left with is x minus 3. Okay, make sure when you distribute that x back in, you would get x squared minus 3x, and you certainly do. X times x minus x times 3, you get x squared minus 3x. Alright, so factor that completely. This right here, so x squared minus 3x, this was step 1, basically. Okay, so here was step 1. That's what I got. And also, if you factor x minus 3, they don't have anything in common. This is as factored as that will get. Okay, if there is nothing in common, multiply the two together, and that is the LCM. Otherwise, what we're going to do is that whole process of circling. I'm going to circle what we do have in common and box what we do not. So when we're looking at the LCM as the common factors represented once, and each individual box factors. So here I'm going to represent what I've circled, the x minus 3. That is one of our common factors, and I'm going to represent it once. Okay, and then you also have to go in and multiply by that boxed factor. So there's that x. Same thing as if we had like 3 times 6. Remember when we did that, we would have 1 times 3, we would have 2 times 3. Okay, these are what's in common, and then this is what we did not have in common. So our LCM of 3 and 6 would be just 3 times 2, because this is what we had in common, this is what we did not. So we have to represent each thing that's boxed. Okay, so here though, what we have are, this is what was in common, and this is what's boxed. So our LCM in this case is x minus 3 times x. Okay, so now we need to, going back to this slide, rewrite our addition and subtraction expressions. So I'm going to have to rewrite this here, 21. So going back to 21, and now using the LCM that I have just found, the LCM of x squared minus 3x and x minus 3, what it turned out was it was x times x minus 3. We found the LCM. We circled what they had in common. After we completely factored them, we circled what was in common and boxed what they did not. So here I am going to rewrite this as its factored form. So when we pull out that x, and plus 3 over x minus 3. Okay, so what I hope you can see is we want to establish this right here as our new denominators. So I don't have to rewrite this at all. This denominator already matches that. However, I do have to rewrite this one to match it. So x minus 3 times what is equal to x times x minus 3? Well, in this case, I need to multiply this by x, which also means I need to multiply the top by x, because think about it. X over x, that's just equal to 1. If you multiply this term by 1, have I changed it at all? No, so I can go ahead and do that. So now what I've done is I've rewritten it to be 9 over x times x minus 3 plus 3x all over x times x minus 3. Because factors, you can commute them, doesn't matter. So now these are identical denominators. What you can just do is add the top straight across, okay, and then put it over your common denominator. Okay, so there you have it. If you wanted to, you could FOIL this out, but that's okay. This is exactly fine. One application, I am going to have you use your book to look over page 678. This is a problem that I am going to be, for your problems and your homework from number 36 through 38, you're going to want to use this example. It's example 5 on this particular page to help and guide you through these problems 36 through 38. As I check over your homework, I anticipate that this might be the most challenging of all this homework, and because it's a word problem, of course, so we are going to have good significant discussion about 36 and 38. The biggest thing is just trying to get yourself set up to do this. So please refer to your resource, your book, example 5, but we're going to be discussing how you set this up, and then once you get it set up, I think that's the hardest part, and then you'll be able to just solve like we've been doing in this video.